there are 40 guys and two girls in a group. Will the two girls be outliers? There are 50 people in a family and there's one person who does not like to gossip. Is that person an outlier? Everyone else likes to gossip. There are 10 people in a group of friends. Four of them like whiskey and six of them like beer. Are people who like whiskey outliers? I have 20 blue denims and one beige one. Is the beige one an outlier? In a group of 50 friends, everyone makes somewhere around 20 lakh rupees per annum. One guy ended up starting his own company and today he makes 1.2 crores an annum. Is he an outlier? So simply what I can say about an outlier in a very basic language for you all to understand, outlier is the odd one out or the misfit. Isn't an outlier basically a data point which is an odd one out or which doesn't fit with everything else? Okay, now that we've understood outliers, let's get done with these numbers and all of this statistical stuff here and the process to calculate it. But whenever you hear outlier, now you should know the intuition, right? Always remember that one guy who did not like to gossip. All right. So outlier is basically there's a lot of blah 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 mentioned over here. I won't get into that. But the important thing that I would tell you is interquartile range. First of all, I want you to understand this, right? Because what these guys do, right? All the science and all the math and all of these subjects, they unnecessarily combine words and make them complicated and scare us off. Do you understand quartile? A quartile is 1/4 of the data. Quarter became quartile, right? 1/4 data is basically a quartile, right? 1% data is basically what? Percentile. The same way. Simple, right? The 10% of the data is what? In the same way, decile, right? Pretty simple. So don't let these guys intimidate you. They just come up with all of these huge names. So interquartile range is what? Quartile is basically a split or a segment of data which has 25% of the data, right? Or 1/4 of the data. Each quartile is basically at a 25% mark of the total data available. So 0 to 25% of the data is first quartile, 25 to 50% of the data is second quartile, 50 to 75 is third quartile, which is mentioned here also, right? Example, Q1 is 25 percentile, Q3 is 75 percentile, like that. Now, what happens? There is a way to technically find out outlier. Now, I'm saying that everyone in my group makes 20 lakhs and I make 34 lakhs. Am I an outlier? Everyone is making around. So someone is making 5 lakhs, someone is making 8 lakhs, someone is making 12 lakhs, someone is making 15 lakhs, someone is making 22 lakhs. I'm saying on an average, everyone is making 20 lakhs. There's someone who's also making 27 lakhs, but the average is 20 lakhs. I'm making 34 lakhs. Am I an outlier? How do you decide? It's tough, right? Because I'm not so much of an odd one out because the average is 20, but I said that someone is making 27 also. I'm making 34. It's not that far off. You guys understand why this method is needed? That if I say everyone is making on an average 20 and I say I'm making 1.5 crores, it's easy. That, yeah, you are bloody hell an outlier, right? But if I'm saying that average is 20 and then I'm making 34, I can't be so sure if I'm an outlier because there is possibility that people are making till 27, 28 also. It doesn't remain so obvious, right? As it was when the difference was 20 and 1.5 crore. So for that, what do? We split the data into these 4 quartiles, and interquartile range is basically what? An interquartile range is fundamentally difference between third quartile and the first quartile. So this is how you make the rule that on a scatter plot, this is how outlier would look, right? This red point is an outlier. When you put it on a distribution, look at these extreme values. The entire distribution around the mean has finished over here, and then you have some value which is so extreme. But to calculate the outlier numerically, you have your Q1 is the first quartile, which is 25th percentile. Q3 is 75th percentile of the data. And this range between these two is called interquartile range. Interquartile range is basically difference between 25th percentile and 75th percentile number in your data. This is your IQR, right? And by the way, this is a box plot that we are looking at. So when you do a box plot shows up like this only. It has a box. That box shows interquartile range. It has these two tails on both the ends, and both of those represent your boundaries for a data point to fall within outlier range or outside outlier range. So it's basically everything outside these two bounds. My interquartile range is this. Everything outside these bounds is going to be outlier. What are these bounds? Q3 plus 1.5 times of interquartile range is the maximum number. Q1 minus 1.5 times of interquartile range is minimum number. Between this minimum and maximum, everything is fine. Outside this range, everything is outlier. And this is also showing here how to visualize a distribution, right? So box plot is basically just this that I explained to you, that you visualize your data in such a manner and you will be able to see what outliers are there in your data. Basically, box plot is typically used when you do EDA for evaluating if the data has outliers or not, or if a particular variable has outliers or not. Make a note of that. Now, when it comes to visualizing the distribution, again, you can know, right? Because this yellow line again in a box plot is your median. Why it is median? Because it is 50th percentile, right? Median is like the center. It will be 50th percentile, or basically the middle value, the center of the data. There are other ways that you look at your data, right? So if you look at this scatter plot, this is also a way. When you plot all your data on this scatter plot, you will be able to see that, hey, this data point, even if it was not red, probably you would have called out that, yes, probably this data point is an outlier, right?